In this tutorial we will create a program which publishes detected objects' position. We will use Jetson Nano, ROS Melodic, a RealSense camera and YOLO darknet version. As a programming language, C++ is used. By publishing position of objects, we will be able to use this information in any other node. For the position estimation theory, please check position estimation of the objects with YOLO v3 using RealSense tutorial. Let's begin from installing the ROS Melodic. There is a script which is useful for installing the ROS on Jetson Nano. Go to the Jetson Hacks page. Copy the URL. Execute git clone command. Now, move to the install ROS directory. Execute the install ROS shell script. This is all we have to do to install the ROS. Now we are going to install Librealsense. Go to this page. Clone this repository. Move to install RealSense SDK directory. Before executing build Librealsense shell script, we need to do some modifications to avoid building process stopping due to memory shortage. Go to the Install RealSense SDK folder. Open the Build Librealsense shell script. At line, time make j nomproc, change nomproc to 1. Execute build Librealsense shell script. Now we will install some ROS packages required to run YOLO with ROS. Install ROS Melodic CV Bridge. CV Bridge converts between ROS image messages and OpenCV images. We are going to modify a CV Bridge CMake file to make it work with OpenCV4. Move to this directory. And OpenCV Bridge config CMake file. Go to the line 96 and change OpenCV to OpenCV4. Save the file. Install the image transport package. Image transport package provides transparent support for transporting images in low bandwidth compressed formats. Install the TF package. TF is a package that lets the user keep track of multiple coordinate frames over time. Install dynamic reconfigure package. This package is used to provide a standard way to expose a subset of a node's parameters to external reconfiguration. Install Diagnostic Updater. Diagnostic Updater contains tools for easy updating diagnostics. It is commonly used in device drivers to keep track of the status of output topics and device status. Create a ROS workspace using mkdir command. In this tutorial we will name our workspace YOLO ROS. To run RealSense with ROS, RealSense ROS package is required. Go to Intel RealSense GitHub page and copy the URL. Move to the YOLO ROS source directory and clone the repository. There are several repositories of darknet ROS. This time we will use this one. Copy the URL and move to the YOLO ROS source directory. Clone the repository. Note that we are doing git clone with the recursive option. By specifying the recursive option, we clone the repository and clones all submodules. If the submodules themselves contain additional submodules, Git will also clone those. Now move back to YOLO ROS directory and build your workspace. We are ready to run YOLO. First, launch RealSense camera. Let's check what topic does it publish. In the terminal, run the ROS topic list command. The topic we need is the camera color image raw topic. Darknet YOLO should subscribe to this topic. Open darknet ROS launch file in the darknet ROS directory. Rename this topic to that which RealSense camera publishes. Now we are ready to run YOLO. We have successfully launched YOLO using ROS. Now let's see what modifications we should do to calculate position of the object and publish it. We have 3 new packages. The Position Messages package contains message definitions for detected object position. The Coordinate Estimation package contains the source code to subscribe to RGB and depth camera topics and publish position of the detected objects. The Launch Inference package contains launch files to launch RealSense, darknet ROS and coordinate estimation node. Let's begin from the Position Messages package. In the message folder we have definition files for 2 messages. Object position message contains name of the detected object and its position. Object positions message contains a header and an array of object position messages. Now let's see the CMakeLists file. A CMakeLists file is generated automatically when you create a package. Basically, you have to uncomment right places and write the required information. The find package command finds a package provided by something external to the project and loads its package-specific details. The message generation package models the build time dependencies for generating language bindings of messages. Here, messages we have previously defined should be written. And here we write messages our message depends on. In this part Catkin package configuration is done. Also, we need to do some modifications to the package XML file. Add message generation and STD messages to build dependencies and execution dependencies. Now let's see the source code of coordinate estimation C++ file. Firstly, we include libraries. Note that we also should include message header files here. In this part we define variables. Note that we defined the variable v of vector type to store received bounding box message information. Here, intrinsic parameters for object coordinate calculation are defined. These parameters could be obtained using the camera color camera info topic. You can check these values by executing the ROS topic echo command. Here we subscribe to the depth camera topic and to the bounding boxes topic. Also, publisher which publishes detected objects coordinates is defined. In this part, the ROS topic is converted to the OpenCV image pointer of 16UC1 format. Note that this format may vary depend on your depth camera. Here, an image from the pointer is obtained. In this function, bounding boxes information is received, and object positions are published. Here, we store bounding boxes information in the vector v. This line means that we do the operations below for each bounding box stored in the vector v. Here, the center coordinate of the bounding box is calculated, and distance to the object is obtained. In this part, we calculate object coordinates using perspective projection transformation. Here, detected object coordinate and class are stored. Finally, we publish the topic and clear the object positions. Now a few things about the CMake_lists file. Firstly, we should find and include directories of OpenCV. Otherwise there will be an error in the later process. Also, we should specify explicitly that this package depends on message targets to ensure the build order gets resolved correctly. Let's see the launch file. Here, we specify that we want to align depth frame to RGB image and set the image size. The original image size is too big, so we reduce it to 640 by 480. Here we are launching YOLO and coordinate estimation node. To execute this code, launch inference launch file. To see the result, open other terminal. Execute source command and execute the ROS topic echo object position message command.